So today, guys, we're going to be looking at quadratic equations, okay? So specifically, all about sketching it, okay? Using what we already know about transformations, okay? So for example, if we have an equation and it says y is equal to x squared, y is equal to x squared graph is going to look something like that. Obviously, that's not perfect, but that's what's going to happen. And it's going to have an intercept of 0, 0, because that's the coordinate, okay? The x value is 0, and the y value is 0 here, okay? So now, if we had, for example, I'm going to rub that out. If we, for example, had y is equal to x squared plus 6, okay? So what's going to happen is, okay, we already know this from linear equations. To find the y-intercept, you have to make x equal 0. Cool, let's make x equal 0. We have 0 squared plus 6, y is equal to 6. So now that means we know the coordinate for the y-intercept is 0, 6. And we'll say it's up here. But what actually happens is, this here, x squared plus 6, is considered to be a vertical translation. Okay, meaning vertical means that way. So it's going upwards 6 units up. So this graph over here is going 6 units upwards. So 6 units vertically translated. Okay, so that's what's actually happening in that position there. Okay, I'm going to show you a question where it's going to go downwards. Okay, so just trying to find that eraser. So let's say, for example, you had y is equal to x squared minus 3. That means this is going to go vertical. That's a vertical translation, but it's going 3 units down. So here, 3 units. The graph is still the same, but it's just moving 3 units downwards. Okay? Then that particular y-intercept is going to be 0, negative 3. You can find the y-intercept by making x is equal to 0. That would be 0 squared, which is 0 minus 3, and left with that. Now, to find out your x-intercepts, if you're going to do this by hand, now we know, always, when we want to find out x-intercepts, what do we always know about x-intercepts? So, always at this point, what's the value of y? Always at those specific points. It could be here, could be here, could be anywhere on the x-axis. We know the value of y, which is this y-axis, at that particular point, the value of y is equal to 0. So you have y is equal to x squared minus 3. Let's make y 0. Okay, now we need to solve for x, because we're trying to find out our x-intercepts. Doing this by hand. We're going to move this here. We're trying to solve for x. That's going to be positive 3 is equal to x squared. How do you solve x on its own? You've got to get rid of the squared. Therefore, it's plus or minus square root of 3 is equal to x. So it's going to be root 3, 0 and negative root 3, 0. You're wondering, where do we get the 0 from? Oh, that's the y value. That's also the y value. Why? Because we made y 0. We're finding out the x-intercepts. Plus or minus, okay, because we're taking into consideration when square root, we can take positive and a negative. Okay, that's your graph. That's your y-intercept. That's your 2 x-intercepts. Okay, and then you got your turning point that happens exactly at the y-intercept as well.